This is a video of amateur radio mobile high-frequency signal strength measurements that were made at the MERAC National Convention in Colorado Springs on September 25, 2017. MERAC, the Mobile Amateur Radio Awards Club, is a group promoting county hunting and mobile radio activities. The annual convention offered a wide variation of mobile setups and participants willing to engage in a signal strength measurement exercise. I am Larry Benko, callsign W0QE, and I made measurements like this at the MERAC convention 10 years ago, but no video was produced. The purpose of this video is to show the signal strength differences of various setups and to help us understand what type of mobile setup would best suit each of us. Capturing the information in the video allows it to be seen by a wider audience. I'd like to thank Tom, W0IVJ, and my wife Beth for their help in setting up, taking the measurements, and the teardown. This is the same measurement technique that I've used several times in the past. A portable mast was set up with two small untuned loops at the top to capture both vertically and horizontally polarized RF signals from the mobile at a takeoff angle of 15 degrees. A phantom switching mechanism allowed the selection of the desired loop antenna. The signals were then measured with a Perseus SDR radio, but in the past I've used a spectrum analyzer. The power of the vertically and horizontally polarized signals was combined into a single number representing the total signal strength. Care was taken to ensure that the feed line was well choked so that common mode current could not affect the measurements. The measurement location next to the hotel in a vacant lot was scouted out and deemed to be acceptable. However, on the day of the event, the large truck traffic in the area was terrible. The nearly continuous truck traffic caused variations in horizontally polarized signal strength. Fortunately, the primary component of the signal is vertically polarized, resulting in data that is still useful and reasonably accurate, but certainly not ideal. Before we look at the mobile setups involved in this test, we should discuss how RF power is measured. The decibel, or dB for short, is a logarithmic measurement where each linear increase in dB represents the same percentage increase in power. The table shows scaling for 100 watts, so that if another mobile station has a signal that is 2 dB stronger than yours, you will need to run 158 watts to have a signal of the same strength. Likewise, if another mobile has a signal that is 6 dB weaker than yours, you could reduce your power to 25 watts and have the same signal strength as they do. The change in signal strength of 1 dB is about the minimum that most people can perceive as a change. This is a setup from N0KV. He has two masts on either side of the pickup bed on a full-size pickup truck, one with 4 resonators, one with 2 resonators, and later on he took one of those masts off and he put a ham stick in its place. The masts appear to be about 6 feet long, and they're also matched at the base with an inductor. This is a setup of WB0PYF, which is a van which has a mast on the back of the van, which mounts fairly close to the vehicle. It appears to be about a 5-foot high mast with a single 20-meter resonator on it at the moment. And consequently, we will do front-to-back measurement test because of the position of the antenna. This is a setup of AB7RW. The antenna is mounted from beneath the vehicle. It appears to be about a 6-foot mast, and it goes up along the back left side to 4 resonators for 40, 30, 20, and 17 meters. This is a setup of AI5P. He's got a receiver-mounted hitch that goes up to a aluminum ladder type structure, which is then connected to a ball and a spring, and it looks like about a 6-foot mast after that, which then connects to 3 resonators. The next mobile was to be WQ7A, but due to an error in my editing, I lost the video. This is a setup of K0FG. He has a Toyota Sienna van with a mast that's about 4 foot high, mounted on the driver's side at the rear up high to 4 resonators. The 4 resonators are 40 meter sideband, 40 meter CW, 30 meters, and 20 meters. This is a setup of N4CD. On the back, he's got a 3-magnet mount, 6-foot mast with 3 resonators on top for 40, 30, and 20 meters. On the center of his roof, he's got another magnet-mounted ham stick, I believe it is, for 40-meter single sideband. This is a setup for NU0Q. He has a small SUV with a magnet-mounted Tar Heel coil mounted towards the back, but not at the back, and on the driver's side of the roof of his vehicle, on a plate that's got 4 magnets and a 5-foot whip on the top. This is the setup of W0GXQ, who has a piece of metal welded to his trailer hitch that goes under the vehicle, up the side, the driver's side, near the body. About halfway up the vehicle, a Tar Heel 200 screwdriver is mounted with a 6-foot whip above it. This is the setup of In5MLP. He has a 54-inch Hustler mast, and on top of that are 3 Hustler resonators for 40, 20, and 17 meters. They're mounted to an aluminum plate that spans the rails of his roof rack. This is a setup of K7S1. He has a 4-passenger full-size pickup truck with a short bed. He has the Scorpion 680 with a 6-foot whip mounted about a foot behind the passenger compartment on the driver's side of the inside of the bed. This is a setup of NF0N. He's got a Subaru Outback with a hitch that's mounted underneath the bumper, and the antenna is mounted into the hitch, which goes up about 30 inches, I believe, here to a Tar Heel 200 screwdriver, and above the Tar Heel 200 is a 6-foot whip. This is a setup of K8Z. He has got a hitch underneath his bumper with a welded-on piece that goes out to the driver's side and up along the side of the body to a Scorpion 680, which is mounted just about at the top of the vehicle to a 5-foot whip above it. This is a setup of W0GXQ, a Chevy Blazer with a aluminum plate that mounts between the 2 rails of the roof rack, and connected in the center of the roof is a non-spring mounted, looks like about a 6-foot mast, which has resonators at 2 heights. He has 7 resonators in total for all the bands, and there's a matching coil underneath underneath the aluminum plate. This is a setup of K7TM, and he wins the award for the most stuff on the roof. But the only antenna that we're interested in is the one that's mounted near the back, which is mounted on a piece of U-channel aluminum with a spring. It looks like a 54-inch Hustler mast with 4 resonators for 40, 30, 20, and 17 meters. The other antennas are all VHF antennas. This is a setup of K0BA. He has a Chrysler 300, and on the trunk he has a 4-magnet mount arrangement, which is mounted on a like a rubbery pad. On top of that is a little Tar Heel 2 and a 4-foot whip. This is a setup for N8HAM, who has a full-size pickup truck, and mounted into the receiver hitch is an 8-foot aluminum mast with a horizontal resonator for 40 meter single sideband only. All right, this is a setup that I run, W0QE. It is a 6-foot mast with 6 resonators at the top, all horizontally polarized. For 80, 40, 30, 20, 15 and 10 meters, and I get a resonance also that's about a 3-to-1 match for 17 meters where I use a tuner. It's connected between the two rails of the roof rack with a torsion bar that's aluminum and 2 aluminum plates. This is a setup run by W0IVJ, which is basically a sheet of aluminum mounted to a piece of plywood. The sheet of aluminum does not mount to the car frame. It is isolated. It can be mounted to the car frame, but it requires retuning, but it was not mounted to the car frame. It's got a 6-foot mast basically above it with a very large capacity hat at the top and a coil. The coil is about 2/3 of the way up, and the coil can be set for 20 or 40 meters as is shown here with a wooden stick. This was a configuration used by C0B. First a 3-foot mast with a 2-foot top hat, and then a 2-foot mast with a 3-foot top hat for HF. Then he also brought 3 other antennas for 160 meters to test. You may also know Rob Sherwood from the fact that he does receiver tests, and he's been instrumental in improving receiver performance for the amateur radio community over the last 20 plus years. Well, there's not much to report on 15 and 10 meters, since unfortunately only N0KV decided to test at those frequencies. Time was of the essence. The weather looked ominous at various times throughout the day, although it never ended up raining hard. And unfortunately, a lot of people just opted for 20 and 40 meters, or maybe 20, 40, 17 or something like that. The results on 17 meters are more interesting since there were 7 participants. Unfortunately, K8Z was having some transmitter problems, so his results should be discounted. The other 6 of us had results that were quite similar. N5MLP, who had the highest signal, unfortunately only chose to measure his signal in the forward direction. Had he measured in the other directions, I would have expected he would have a very small front-to-back ratio, since he had an incredibly center-mounted antenna on the middle of his roof. I had a off-center mounted antenna on my roof, and I had a 4.2 dB front-to-back ratio. Even though it looks like it's 4.3 according to those 2 numbers, everything's just averaged to one decimal place. K7TM, NF0N, and AB7RW all had antennas that were mounted near the end of their vehicle or on the back of their vehicle, resulting in increased front-to-back ratios. However, their forward directions powers were quite good. So the lesson to be learned here is, obviously, if you wish to have a more symmetrical pattern on the higher frequencies, mounting near the center of the vehicle is definitely advantageous. The results on 20 meters show the most competition. W0GXQ was at the top of the list. However, he transmitted only in one direction. And if you transmitted in a couple directions and you had a little bit of front-to-back ratio, that hurt your average signal. Nevertheless, there were plenty of people who had an average signal level that was only a dB or so below his signal in the forward direction. If you notice, I had a 4.2 dB front-to-back ratio on 17 meters. With the same antenna position on my vehicle on 20 meters, it was 1.8. This is a general trend as you go lower in frequency, that the front-to-back or front-to-side ratios drop as the frequencies get lower. And you can look at all these descriptions of the antennas and maybe draw some conclusions. Generally, a smaller coil will cause you a little more loss. Generally, mounting an antenna close to the vehicle, especially the high current part of the antenna, will cause you some extra loss. KB0BA was having some transmitter problems in that the radio was shutting down and it was hard to make the measurements quickly enough. Therefore, I would treat these values as being suspect. But nevertheless, this shows that most of the mobiles have pretty good signals on 20 meters. And since 20 meters is the most popular band, I guess that's a good thing. Those who would like to have a little bit more symmetrical signal might want to consider another antenna at some point in time that's a little more centrally mounted on the vehicle, although that's not always an easy thing to do. The results on 30 meters show 8 participants with a wider variation in average power than I saw on 20 meters. Nevertheless, W4SIG had the best signal, in the forward direction, that is, and he would be expected to have some front-to-back ratio, so he might have been hurt a little bit if he had measured in the rear direction. AI5P, which was the only station to transmit in both directions, forward and backward, and he shows a 3.6 dB front-to-back ratio with an antenna that's mounted off the back of his vehicle, although the coil is fairly high on that antenna. Nevertheless, I can't explain why there's a 12.8 dB difference without looking at each individual antenna. I don't know why W0GXQ signal is nearly 10 dB down. I don't know where he had the 30 meter resonator relative to the other ones. There might be some interaction. That's hard to say. But nevertheless, these are the results with, again, W4SIG on top. The box around the comments section for AB7RW is an artifact of how I copied the data from Excel and has no meaning. It would be interesting if we had more time and had I seen the data in advance of after I got home to try to have analyzed why K7TM, W0GXQ, and K8ZZ were down that far in signal strength. I don't know if it was power. Everyone was supposed to be running 100 watts, and everyone said they were running 100 watts. I don't know if it was a power issue. I don't know if it was something else, but it would have been interesting. It's a shame we don't all live closer and couldn't get together more often and do these kinds of things and resolve this stuff. But nevertheless, those are the results for 30 meters. 40 meters was well participated in as expected. And the first 3 places go to stations which had, the guys are not county hunters, but they were stations that had large capacity hats. NC0B brought 2 antennas for 40 meters. He brought one for 20 too. The 20 meter antenna he fared well on, but he excelled on the 40 meter antennas. Both the 2-foot mast with the 3-foot top hat and the 3-foot mast with the 2-foot top hat were on the top of the list. W0IVJ was 3rd. His large top hat certainly helped also. And all 3 of those guys, I suspect, had very low front-to-back ratios. W0IVJ's was only 0.7 dB with his antenna nearly exactly in the center of his vehicle. I was in 4th place with a more conventional antenna from the county hunter point of view, where you would be concerned about quicker band changes without getting out of the vehicle. The first 3 antennas required a vehicle exit to change bands. One thing we start to see on 40 meters is it's tough to make an antenna efficient on the top of the roof without having some capacity hat or large, stingers or something else sitting on the out from the antenna. The antenna can be moved lower to ground, but if you move it lower to ground, you don't see a large signal improvement. Even though the antenna gets larger, you run into the issue of ground losses rising. So that causes a dilemma as to whether you put the antenna up high or not. Clearly, a large vehicle helps, and clearly, if, the maximum possible antenna height you can tolerate. Although most of us have pretty well decided that numbers like 12 feet, maybe a little bit over 12 feet, are just about all we can tolerate without hitting too much stuff. Depending on where you live in the country and where you go mobile, if you stay on the main roads, you're a little bit better off. 13 feet 6 inches is pretty much the standard for trucks. And if the branches are lower than that, usually they'll prune them for you, just with their ongoing traffic. However, if you live in a place where there's a lot of tree cover and it rains, that 13-foot 6-inch limit comes down when the foliage gets wet. So it's a constant battle as to what you do. But we see a fairly large variation in signal here between the top stations and the stations that are down a ways, and that indicates the fact that 40 meters is a tougher band to have a good mobile signal on, and that trend will continue as we go to 80 meters, and 160 becomes extremely hard to have a good mobile signal on. Here are the 80 meter results. I misspoke earlier when I said NC0B did not participate in 80 meters. He did, and he's in first place. His capacity hat showed its value. And we look at the other mobiles and we see a fairly large drop-off again. It's even harder to have a good 80 meter antenna than it is a 40 meter antenna. Although I attribute my result on 80 meters to the fact that I've got a 6 foot vertical piece, but I've also got a 6 foot horizontal piece on 80 meters, which effectively makes the antenna a little bit larger. That certainly doesn't hurt anything. But again, we see the same trend. Front to back ratios are extremely small. Doesn't seem to matter where you mounted the vehicle. WB0PYF has his mount on the back driver's side of the minivan close to the vehicle. He's only got a 0.7 dB front to back ratio. W4SRG, again, same kind of a placement, 1.3 to 1 dB front to back ratio. It turns out that you can mount the vehicle pretty much anywhere you want. It's hard to get a good signal, but nevertheless, it's pretty easy to have a signal that's fairly non-directional. One thing that is of interest on 80 meters is the fact that if you build an antenna that's fairly efficient, you'll be constantly battling with the fact that the bandwidth of the antenna is very, very low. I don't know what NC0B's bandwidth is. My bandwidth on 80 meters is about 10 kilohertz before I have to put a tuner in the circuit. And if you have a bandwidth of 30 or 40 kilohertz on 80 meters, you can almost guarantee the fact that your antenna is pretty inefficient, and it would show in a test like this. I cannot explain the results from WQ7A on 80 meters. His 4 foot mast below his tar heel and with an 8 foot whip on a large SUV should have produced a much higher signal I would have suspected on 80 meters, and I don't know why it didn't. I can understand on higher frequency bands he has a fair amount of current, high current that's near the vehicle, but on 80 meters that really doesn't matter as much, and I would suspect that he would have done better. Either there's something I don't understand here, or something else. There's obviously something going on, but nevertheless, that seems to be an anomaly. I don't know of any counting activity that's going on 160 meters, but I thought I would show the results for the 3 antennas that NC0B brought. They're all large antennas, and they all were within 1 dB of each other, which is kind of amazing. I would have thought the second antenna in the list with the 4 foot hat would have been on top, but it was not. Nevertheless, these are the results we got, and it just goes to show the effectiveness of a large capacity hat in terms of antennas, especially on the lower frequency bands. The results this year and the results from 10 years ago when I did the same test show a surprising amount of similarities. The larger antennas seem to win always. The antennas that are well made, mobile installations that are well done, all seem to do better. We can draw a lot of conclusions from this, but one of the conclusions we can draw is the difference in antennas. I was expecting this year to see some different antennas, such as the W9UCW flying saucer antenna that was in the May 2017 QST. I didn't see any of those at all, such as is shown in the picture here. I'm not sure this is quite one in the picture, but it's an early version of such a thing. I didn't see any of those. I was thinking since W9UCW is a county hunter that some people will be running that antenna. They may be, but they didn't show up for the test. Also, 10 years ago, that we saw several, at least three, of the little ATAS-120 antennas, and they did not do very well. They were tiny little screwdriver antennas rated for 100 watts maximum, and they didn't do very well. There were none of them this year. They were replaced by some smaller screwdrivers compared to the large ones, but they were much larger than the ATAS-120. Also, I didn't see any antennas like the Outbacker or things like that. It seems to be people have gravitated to a slightly different set of antennas. I think that's primarily good, although it'd be nice to see some of these other antennas that aren't as popular, available for comparison. A couple other things I noticed. One was a lot of stations had a huge amount of problems with producing a 100-watt carrier. Depending on your radio, producing a 100-watt carrier is pretty simple. In most radios, you can put the radio in the RTTY mode and squeeze the mic button, and that'll generate a 100-watt carrier. I suggested also to people that they turn the mic gain down to 0. They put the radio in the FM mode and do that, and they thought that the radio would only produce 50 watts in the FM mode. I don't see any reason why an HF radio would back off to 50 watts in the FM mode, because 100 watts RTTY is not a whole lot different than 100 watts FM. But nevertheless, people had problems doing that. There were also some setups where the setup was unable to generate 100 watts for any period of time long enough to capture measurements that I needed to capture without the radio either resetting or something else happening. That was indicative generally of low voltage due to something. You can probably wiring issues or maybe a battery that's not real good. But those are all indications of things that perhaps could be improved in your setup. Also, while we're talking about things that could be improved in a setup, there are things that you can do, like a battery booster. A battery booster is not a end-all to people's problems, but in a standard car with a 12-volt system, when you're charging the battery's got 14.5 volts on it from the car. That 14.5 volts does not necessarily make it to your radio. A perfectly good battery that's charged to 14.5 volts, you can still have a problem if the wiring to your battery has too much resistance in it. People will sometimes draw I don't know, maybe 20 amps from a circuit maximum. They'll try to draw that from 2 parallel cigarette lighters. You can go directly to the battery, but you still have to worry about the wire resistance itself. And those topics are things that are probably out of the realm of this video at the moment, but they're certainly easy to analyze. A good way to do stuff is to bring heavy gauge wire within a few inches of the radio and then let the last few inches be something that's more flexible. I once repaired a radio connector for a guy who had brought like 6 gauge wire directly to the back of the radio. And the wire was so stiff that every time he moved the radio and stuff, it was really hard on the pins in the connector, and ended up damaging the connector pretty regularly. A battery booster can be a big help, especially if you wish to run mobile with the ignition off. A system that works with the ignition on and the battery at 14.5 volts can easily tolerate a volt or two of voltage drop between the battery and the radio. However, as soon as you turn the ignition off, the car no longer charges the battery to 14.5 volts, and the battery float voltage will be 13 perhaps volts if the battery's new, and lower than that if it's not new. And the voltage that you drop beyond that gets very close to where the radio might cut out. Particular radios like the ICOM 7000, I'm sure others do also, 11 volts, and they're toast. They no longer will operate. And many of them just power down until the voltage rises again. So a battery booster is a good plan. I've had people tell me, though, that a battery booster is bad because it can drain your battery to 0. Most battery boosters will boost the voltage when it's above 10 volts. When it gets below 10 volts, then they cut out too. But it gets you an extra volt or two of operation. And remember, the battery booster does not need to be placed at the battery and drain the battery to 10 volts. It needs to be placed at the end of the wires before the radio. A battery booster is best used when it's near the radio because then it gives the radio constant voltage. And almost all mobile radios are much happier at 13.6 volts than they are at 11.5 volts. Anyways, these topics and several others can certainly help contribute to a more pleasurable mobile experience. But nevertheless, I appreciate everybody who came by. I enjoyed seeing people again. It's been a long time, and hopefully people will get something out of this video. And perhaps we can do it again in the future sometime. 73, W0QE, and I certainly had a good time doing this.